Hello, everyone, and welcome to the Ask the Expert webinar, PROC BGLIMM, the Transition to Bayesian Analysis. My name is Thiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenter, Danny Maudlin, a senior analytical training consultant here at SAS since April 2011. Prior to SAS, he taught at the middle and high school levels. He also served as a teaching assistant at the University of North Carolina at Wilmington and NC State University. Danny holds a Bachelor of Science in Mathematics from Elon College, a Master of Mathematics from UNCW, and a Master of Statistics from NC State. With all of that out of the way, why don't we turn things over to our presenters so we can get started? Danny, please take it away.
Thank you so much, Diego. I appreciate it. I'm going to go a little bit off script here and not use actual slides. I'm actually going to be using a Jupyter notebook. So I'm going to go ahead and quickly switch to sharing my screen here and share that lovely Jupyter notebook with everybody. So hopefully that is now going to be showing up on your screen now. I've tried to size it so that it should be pretty legible, but do let us know if there's anything that can helpful with that. So you're here to learn about Bayesian analysis. Specifically, you're here to learn about the BGLIMM procedure. And the BGLIMM procedure is what I have been calling the smooth transition to the Bayesian world. Now, you have to realize Bayesian analysis has been around since the 18th century, thanks to the Presbyterian minister, Reverend Thomas Bayes. Now, but if you think about it, how long has SAS actually been working and dealing with Bayesian analysis directly? Well, I can tell you that it was about the time that I started working here at SAS, and that's been about 15 years ago, because I joined SAS when our Bayesian course that we actually provide here was being written by a colleague of mine and a former professor of mine. Now, when the Bayesian analysis was first brought into the idea of SAS, the way things were kind of dealt with from the developers was there were certain procedures that were selected that were given a Bayes statement as part of the analysis possibilities. Those were GenMod, PHReg, LifeReg, and CountReg. Now, when a person says, oh, well, that's cool, that's a procedure I know, and I can just add a Bayes statement, I always like to warn people and say, please realize those procedures were originally written for the classical realm. I basically say, if you have a Bayes statement, that's like putting a Bayesian blanket across a classical procedure. And what always happens with blankets? They fall off. They don't adhere very nicely, because what you're going to notice if you're trying to use things like GenMod or PHReg or LifeReg in a Bayes statement, you are very limited in what you are going to be able to do easily with that Bayes statement. Now, don't get me wrong, you'll be able to do plenty, but if you start trying to get a little bit advanced, things start going a little bit awry, and it might be even easier or better to have simply just moved to the MCMC procedure. Now, the MCMC procedure was the general purpose catch-all, purely written for Bayesian analysis procedure by our development team. Now, most people say, oh, cool, then I'll just go to PROC BGLIMM. Let's go to PROC MCMC, excuse me. Well, when you start looking at the way the code has to be written for that and things along those lines, there's a little bit of a learning curve with that. You have to get adjusted to realizing how you need to write the code for the MCMC procedure. So the developers believed that there needed to be a middle ground. There needed to be something that could be beneficial, that would alleviate some of those issues from just a Bayes statement, but at the same time not force you to have to go into a very different type of coding structure like MCMC did. So they've created BGLIMM. Now, BGLIMM stands for Bayesian Generalized Linear Mixed Models. And why did they pick, now, do you see the hidden term of GLIMMX starting to appear in that procedure name? Yeah. Why did they pick GLIMMX to kind of build off of to create this BGLIMM area? Well, you have to realize that when you start with a generalized linear mixed model or general linear mixed model, you do have a lot of possibilities and already are looking at some generalizations of being able to deal with a lot of different types of problems. Think about this. Remember how you might have heard some people in the past that say, oh, well, anything you do in reg and GLM, you can do in GenMod, right? Well, that's when you bring or in prop mixed, right? Well, the thing is, when you're trying to do something that's GLM-ish or reg-ish in mixed, prop mixed, you just don't put in the random effect, right? So when you capture something like prop mixed or you capture something like PROC BGLIMM, you've captured a lot more. And you have a lot of abilities of taking models that you've already created, multitudes of models that you've already created, and you can bring them over very nicely into the Bayesian realm. So I want you to think about your own situations. Have you been in a situation where you have already created models for your work using reg, GLM, GLM select, GenMod, mixed, and even GLIMM-mixed? If you have, BGLIMM is going to be the nice way that you can make this very smooth transition across. Because again, because of the generalizability of the way that we can say, oh, let's keep things in the normal world. Oh, wait, no, let's change the distribution and put it into one of the exponential families. Oh, we need a random effect or a repeated measure. Or no, we don't. We're going to have that flexibility as we kind of go through things with this. And again, you can go back and kind of remind yourself of how general linear mixed models are built and how all of the different areas are there. And you can even remind yourself of how taking that extra step forward for a generalized linear mixed model works, and that expansion of being able to leave the normality situation or stay in normality, but think that there's a different relationship between the expected value of your response and your linear predictor, and bring in things like link functions with all of that. Now, the one thing that people kind of got confused about, if you are an avid prop mixed and PROC BGLIMM person, and they love to use those procedures, do you remember that in prop mixed you have random and repeated? And then in PROC BGLIMM you have random and then random underscore residual underscore. Remember that? I have good news for you. The developers listened to the grumblings of multitudes of people, me included, that basically said, why did we go away from the word repeated? Well, when we get into BGLIMM, what you're going to notice is even though it is very much coined after the idea of how GLIMMX works, we're going to bring back repeated instead of this random underscore residual underscore. They are basically interchangeable lines from prop mixed to PROC BGLIMM, but I'm happy to say that if you are very accustomed to a random statement and a repeated statement, that is going to be back in prevalence for the BGLIMM procedure itself, which is going to be extremely nice. Speaking of prop mixed, let's check this out. So let's look at a sample prop mixed program. So we have a toy company that has got toys that have to be put together at 3 specific locations. And we have 3 different adhesives, adhesive A, adhesive B, and adhesive C. Now, of course, we all know when you give a child a toy, what's the first thing they try to do? They break the toy, right? Or at least they try to break the toy. Don't know why that happens. But the idea here is they want to figure out what is going to be the best adhesive to use. Is there a significant difference in the average breaking strength across the adhesives? But what they do is they randomly select 7 toys off of the assembly line. And when they do, they then apply all 3 adhesives to each of the 7 toys. Now, the question is, do you want to be able to speak about the differences of the average breaking strength for just those 7 toys, or do you want to generalize it across the entire toy line? Well, you want to do that generalization, right? So that introduces the random effect of toy. So now we could, I don't know if that will happen, of adding the repeated statement back into GLIMMX. That was a developer call, so I don't know if that developer will want to switch that back, but good idea though. Look at that PROC mixed code. Does that look familiar to you? Does that look familiar to you? Yeah, that is very basic structure, or in this type of an idea. This is our typical PROC mixed call in this typical idea. Pretty simple code, right? Pretty simple code. Okay, would you like to see what this looks like if I was to put this into PROC MCMC? Okay, imagine PROC BGLIMM does not exist. Okay, pretend PROC BGLIMM does not exist. So those first few years of us breaking into the Bayesian realm. Check this out. That is your PROC MCMC code for the same problem that you just saw using PROC mixed. Now, if you look at this problem and you go, what in the world is all of that? One thing that I always like to tell people whenever they are reading or writing anything, especially in PROC MCMC with the Bayesian analysis, is read it from the bottom up. So notice we have a model statement down here at the very bottom that says the breaking pressure, the pressure it takes to break the bond, is normally distributed with the mean of mu and a constant and a variance of S2T, right? That's the residual variance. Step up. The mu is x beta plus z gamma. That's what that line is giving me. Then the random statement is, oh, well, the random effects are my gammas. They're normally distributed with the mean of 0 and the variance of S2G. That S2G and that S2T are going to combine to give me the variability of y in my particular problem. Here's that little subject by toy. How does SAS know when you go from one random effect to another random effect? You switch toys. And then the rest of this is telling SAS who are the parameters in the problem and what are their priors. The rest of that is core elements that we need for the Bayesian analysis. But if you look at that, you might sit there and go, I don't know if I really want to write all that. So the question becomes, would you like to see how it looks in BGLIMM? Check this out. That, everybody, is that mixed model written in BGLIMM. Now I want you to look at that very carefully. Is that pretty much the exact same structural code that you just saw in our PROC mixed? Yes, it totally is. By the way, do not get over concerned that in PROC mixed I said random toy, and here I said random int subject equals toy. That is nothing more than just creating a block diagonal design for my G side random effects and my G matrix. All I'm doing here is I'm trying to be a little bit kinder to SAS, especially in the linear algebra calculations and the linear matrix calculations, because inverting is easier for a block diagonal matrix than it is for just a general matrix in that case. But they are basically equivalent lines. So don't think that that's something special with BGLIMM. That is just something that helps with the math. Now, if you look at that, doesn't it seem like you can do that very easily? You can take pretty much any code that you might currently have and bring this across into BGLIMM. But that was the whole idea. The developers wanted to be able to give you a way to kind of very quickly kind of jump from an analysis that you might already have to something that you can say, well, I want to kind of go ahead and take this into a Bayesian viewpoint quickly, if I can. Now, granted, though, will everything be able to be brought into BGLIMM? No, it will not, because there is still a limitation. There are still going to be limitations on the types of priors that you can bring in. There's going to be limitations to things that you might be able to do with the structure of your problem. But when that happens, do we still have your back? Yes, we do. That is when you're definitively going to have to move to PROC MCMC, much like how before BGLIMM was in existence, if you went outside of the box for the Bayes statements in GenMod, PHReg, LifeReg, CountReg, You had to go to MCMC. Same thing here in this type of an idea. But in a lot of cases, in a lot of situations, you're going to be good to go when you're dealing with trying to take some of your current model types and bringing them across into a Bayesian realm. Now, let me give you a little bit of, since this is probably a newer procedure to most people, let me give you some details, if I may, before we actually start looking at some examples in actual code. So there is a whole suite of covariant structures. So if you need a covariant structure like AR1, toplets, compound symmetry, of course, our lovely friend unstructured, both for the G side and R side elements, we do have a suite of those available. We do have covariance heterogeneity modeling. Anybody know quickly what that means? That's that group equals optioning. For example, if something is compound symmetry, but you might want to have different estimates for variance components for this group versus that group, same structure, just different parameter estimates, that's that group equals possibility. You've got that inside of BGLIMM. There are built-in priors. This is the fun part. Yes, you do have some customizability of the priors, but you are going to have a structural group of priors for each type of parameter that can be possible in this type of scenario. When you deal with model comparison, you'll still get the DIC statistic. Again, that is the Bayesian's counterpart to AIC, BIC, things along those types of ideas. And then, of course, multi-threading. Okay, don't read into that. Bayesian analysis in its heart of hearts. Yes, Bayesian networks are in VIA for CAS. But when you're trying to deal with the idea of looking at dealing with multi-threading, that's dealing with the cores inside of your computer, not divide and conquer type of an idea. So you do get to be able to utilize multiple cores if that is something that you would like to be able to do inside of your analysis. Let's talk syntax for a second. If you have seen the Bayes statement options that are there, if you have seen the options in the PROC MCMC line itself, these are going to look familiar because it's basically the same thing in terms of what data set, this random number seed. By the way, using a random number seed is very good for replication if you want to come back to a problem. Feel free to pick whatever your favorite seed is. Thank goodness it doesn't have to be prime anymore. I remember the days when random number generations needed a prime number to create the seed. Also, really quickly, if you do pick your favorite random number generating seed and you don't get what you want in the results, don't change the seed. That's like changing your alpha after you see your p-value. That's not a good idea. Please don't do that. By the way, my favorite random number generating seed is 8675309. If you get that reference, thank you. Outpost is where you will save out the chain. Always a good idea to save out the posterior chain because any post analysis you need, you don't want to have to go back and rerun everything. Burn in, how many iterations, what statistics, what diagnostics, what plots do you want to see? By the way, that stats equals, diag equals, and plots equals, can I tell you my favorite thing to put after that? All. Stats equals all, diag equals all, plots equals all. That is going to give you everything that you can get. Trust me, be prepared. It's going to give you a nice collection of items, but trust me, they're there for a good reason in that particular case. Now, what distributions and what links, because remember, if this is tied to things like GenMod and GLIMMX, what are going to be those distributions and links that we can particularly use? there is a list of 9 response distribution types that we are going to have available to us in BGLIMM, and there are 8 of the link functions that we will be allowed to use. Any combination from the distribution list and the link function list, you got a problem that we can use. Again, very similar to what you would have seen in GenMod already and in GLIMMX already. And notice that the distributions and the links are pretty much very typical ones that most people will have already been wanting to use, or you will see in most of their typical problem types. When it comes to your random statement and your repeated statement, when you're talking about the G side and the R side random effects, if those are needed in your problem, you have very much similar structure to what you would have in PROC mixed and PROC GLIMMX. You have subject equals, group equals, type equals. Notice that 13 choices when it comes to what type of covariant structure you want to use for your G side matrix. And much like the mixed and GLIMMX, you can have as many random statements in BGLIMM as you want to make your G side matrix as complex, in your G matrix, G elements as complex as you want them to be. Okay, so yes, you have very similar structures to the way that mixed and GLIMMX were working. When it comes to repeated, same idea. However, like mixed and GLIMMX, you only get one repeated statement. Okay, you can have as many random statements as you want. You're only allowed one repeated statement. So you get one way to talk about what's happening on the R side in that particular case. So again, you're noticing I'm not really changing a lot of the dynamic structuring of code when it comes to something like GLIMMX moving over into BGLIMM. And so that, again, is that simplicity that the developers wanted to be able to take models that we've kind of already got and bring into the Bayesian realm pretty quickly. If you're interested in the order of how things are updating in terms of the sampling, the first thing that it does, by the way, it tries to use Gibbs sampling as much as it can. Gibbs sampling is the one that comes up when you have conjugacies. Conjugacies basically is when your prior and your likelihood match up nicely mathematically to get closed form solutions. That is the ideal situation, but not everything matches up very nicely. And so that was the whole reason why we needed Markov chain Monte Carlo to help us in the Bayesian realm. But BGLIMM tries to push through Gibbs sampling. I'll point out how you can tell if there's something that happens where it has to go a little bit off script for that. But the order that it goes through is it looks at your fixed effects first, then the random effects, then the G side parameters, and then the R side parameters. Oh, and by the way, missing data, anybody? If you have missing response values, those missing responses in the data set will be treated like parameters and sampled through a posterior viewpoint as well, meaning you will get a posterior interval, a credible interval when you're looking at a Bayesian answers for those. Okay, here's where it gets interesting. Priors, those prior distributions, this external information beyond the data that I want to bring in. Remember, external information being brought into the model is the core of Bayesian analysis. Remember, most people say, why in the world do we need Bayesian analysis? We've already got classical. Well, you have to remember, the Bayesian twist allows this external information, whether it be from a subject area expert, whether it be from studies from the past. We want to bring that information in and combine it with what's going on with my current data that I have. And the nice thing is that the end result of this, even if I don't know anything, I can use what's called a non-informative prior. But the end result is instead of getting a point estimate and a standard error, I get a posterior distribution on where I believe the parameter resides. So in that type of an idea, what we're trying to do is we're saying, oh, okay, I actually can now talk probabilistically about my parameters. For example, have you ever found yourself in a situation where someone said, hey, what's the probability that beta 1 is probably bigger than 4? Can't answer that in the classical realm. You can answer that in the Bayesian realm because we can finally talk probabilistically about the parameters in that type of an idea. Oh, and by the way, another really good thing is that credible interval that I talked about. Think about confidence intervals in the classical realm real fast. Have you ever heard someone interpret a confidence interval by using the word chance or probability? If you've ever heard that happen, did you stop them? Because you're not allowed to say, oh, I have a 95% confidence interval. There's a 95% chance that my parameter's in there. No, you can't say that. You can't invoke probability to answer that question, that statement. Because again, in the classical realm, the parameter is a fixed entity. In the Bayesian realm, it's a random entity. So we can then have an answer that would be a probability density, and I can speak about things in a probabilistic manner. So that's, again, the benefit. And the whole reason why most people will move over into the Bayesian realm is to answer questions that the classical statistician can't really touch. Here are your priors. For your fixed effects, your betas, a flat constant prior or a normal prior. Normal priors make sense because the way I always tell people about how you can figure out what type of distributions work well with some of your parameters is look at the support of the parameter. Fixed effects, your beta hats could be negative, could be positive, could be zero. So I need a distribution that can handle the number line. Normal is pretty good for that. Your scale parameter, your variance components here. Inverse gamma, gamma, or improper. Well, I need something that can handle the positive territory, get as close to zero as possible, but not touch it. Well, that's the inverse gamma and the gamma. The G side, the R side, you can see the choices there. You have inverse Wishart. Inverse Wishart is a great distribution when you're talking about variance covariance matrices. That's why it is present in both the G side and the R side. But you do have a few extra pieces and possibilities in the G side, but that is your list right there. I do see one question that popped up about multinomial or ordered multinomial distributions in BGLIMM. As it is right now, they are probably still, they're trying to add more possibilities to it. So I would say be on the lookout for that. But they started with the core type of distribution. So I am not going to say that it will not show up. I am saying that it will probably show up probably later on. So just be on the lookout for that. But again, most people deal with binomial rather than the multinomial in that particular case. But again, that's something that, you know, you can make suggestions to the development group. I'm still making suggestions to them. So fingers crossed that the timeline on that works out. But again, I wish I knew what was on their nice little timeline, because if it was something that I could go over there and kind of move something around, I definitely would. Because there are definitely things that I'm still kind of going, come on, add it in, add it in. But you have to remember, you know, SAS has been dealing with Bayesian just for basically the most recent 15 years or so. So we're catching up, but we're getting there really fast in that type of an idea. And that's thanks to our development team with that. All right. Yes, they are restricted to the exponential family because, again, it's pulling the idea of GLIMMX and MIX and GenMod. Excuse me, GLIMMX and GenMod ideas. So yes, it would be exponential families for that. If you do want to have like your own mixture distribution, that's MCMC. You're going to be going for that already. All right, you ready to see some examples? I know you've been sitting here going, yeah, we need it. Let's see some code. All right, here we go. So by the way, if you're wondering where I'm at, I'm actually in VIA for Learners. So I'm using VIA for Learners. On VIA for Learners, we actually have a Jupyter Notebook area and a standard VIA area. So that is where I am using with this right now. So that's where I've got the SAS kernel that's connecting me in and allowing me to do all of this. By the way, all of this code that I'm actually showing you, if you are on VIA, you could just be in SAS Studio and run it on the just a typical run from that actually would be perfectly fine. It will run perfectly fine inside of VIA as well. Or if you're still running on SAS 9, all of this runs there too. Here's a simple linear regression with the class variable. So basically this is something that would come from, say, GLM. And if you notice, very similar structure of the code. You have your class statement, you have your model statement. Notice I put normal distribution Notice I said nothing about the link. Same rules apply. Remember, if you tell it the distribution, it has the canonical link already in mind. But if you don't tell it, if you want that to be a different link, I definitely can tell it. Here's where I can make a little bit of a switch here. Coef prior, what is the prior for my coefficients? Normal, you get the 0 mean for free, but here I'm doing the 1 million trick. If anybody's ever taken any of my other talks, I always talk about a minimally informative prior. Think about a normal distribution centered on 0. Stretch that variance to 1 million. I've made that pretty much as flat as I possibly could make it. This is basically what I would do if someone said, hey, do you have any prior information about where these parameters might be? I have no clue. This would be the type of prior that you would want to put in those types of situations. But if someone does have something, you can definitely tell them in that type of a viewpoint. I would say instead, for the questions about the BGLIMM, can use BGLIMM to export the design matrix. I don't believe that BGLIMM has a out design option. Glimmix does. So use Glimmix to do that, to move to MCMC. That would be the cleaner one for that. Here's your model information. And that's, of course, because MCMC doesn't have a class statement. Here's this idea. Look right here. Sampling algorithm conjugate. So if I was in PROC MCMC and I was trying to be worried about did I converge to my answer, because remember, we're not converging to a point anymore. We're converging to a distribution now. So I need to be able to kind of justify, have I converged? I love it when the word conjugate shows. When the word conjugate shows, then that kind of tells me, Danny, you converged. But the question is, do I have a long enough saved chain? Is everything else looking okay? That's the reason why I would look at the other diagnostics to kind of look at this. The burn-in is automatically at 500. The iteration amount is at 5,000. By the way, remember, SAS separates those. So it'll burn in for 500, then it will iterate for 5,000 more in that type of an idea. There's my random seed. There's my priors. There's my scale. So it's using an inverse gamma, and it's using a normal for the betas. It's using an inverse gamma for my variance component. There's my posterior summaries and intervals. So if someone needed a quick answer about the parameter for age, I would say, oh, the posterior mean is 3.1130. But then if someone says, well, where could it be? I would say, oh, there's a 95% chance that the parameter for age is in this negative 2.87 to 9.37 territory. Okay. Now, if someone said, oh, can you score new data with this? Yes, you can, but that's going to be a little bit different than just sitting there and plugging in the values under that posterior mean. That would just be one value. If I wanted to actually talk about scoring, there are actually 5,000 iterations that need to score that new data observation that you have so that I can get a proper posterior distribution on that answer, that prediction that's there. Now, notice I did not put any other major options inside of here, nothing like the plots equals, stats equals, things like that. So you're looking at just general, here is the typical default output. The default output will give you just the effective sample size. But let's play with that mixed model situation here a little bit. So here's that toy data. Here's prop mixed, what I would have run from prop mixed. Here's all of the output. We're using REML inside of prop mixed, running through all of that. This is output that you would have been used to. Look at this. Here's the variance estimates for the toy variability and the residual variability. I don't know about you, but I'm slightly concerned here because I only have 21 observations. I have 3 observations for each of the 7 toys. So I don't know about you with using random effects and mixed models, but I don't trust my sigma squares anymore. The answers that are coming up from the sigma squares, I don't trust them because asymptotics is breaking down. Here's another bonus of Bayesian. Bayesian is really good at not having a crutch of asymptotics. if we have a very small or a smaller sample size or a vastly separated through categorical variables that basically says, oops, my element of asymptotics is breaking down, Bayesians say, I don't need asymptotics. I think I can give you a better and more proper estimate of what would be in that type of an idea. The negative age range, remember that was talking about the beta hat for age. So it would be either a negative effect or a positive effect. So this is looking at the beta hat for that. So that would be the relationship. So this, some people might look at that and say, well, you're crossing 0. There's a different way to kind of deal with how important a variable is, or if that variable is important in the mix for that model, because we don't use p-values inside of Bayesian analysis, especially when it's deciding if a variable is important or not. Now, check out the code for BGLIMM on that same toy example. It's just like this right here. When I run it through, conjugacy, perfect, lovely. Thank you, thank you, thank you. I'm so happy for that. There's my prior informations right here. There's my posterior summaries. Now, wait a minute. I wonder how different it is from a classical sense to a Bayesian sense when the Bayesian says, I don't know anything. Because if you put in non-informative priors, the data takes over. But wait a minute, if the data takes over, isn't that the way that the classical world feels? Yeah, but even with that, the Bayesian can still talk probabilistically. Let me show you something. Here, I wrote out a comparison table for you. The left column tells you what were the parameter estimates that came back from PROC mixed, the classical viewpoint. When I used completely non-informative priors, no additional information, the right-hand side shows you the posterior means of each of the parameters in the problem. What do you notice? They're pretty close. But Danny, your toy and residual variance components are different. Yeah, I warned you about that. I probably can't trust the answers that came out from PROC mixed because the asymptotics broke down. I honestly think that the Bayesian answers are the better answers for those variance components. But again, I think this is probably why classical statisticians are upset with Bayesians, because if we treat everything as we don't have any additional information, all non-informative priors, we can emulate the answers that they get, but we can still talk probabilistically. I think that might be why they might be mad at us sometimes. But that's just me thinking out loud on that one. Kind of cool, right? And did you also see how fast that went through? That's another bonus too. Here's a GLIMMX call. So let's look at a horseshoe crab data set. I've got the data right here for you. And here's my GLIMMX call. Notice I'm going to do a count. I'm doing a count response variable. That's a Poisson. It'll have a log link against it. And I have a random effect of different sites that I'm looking at for these horseshoe crabs. So again, here's the GLIMMX call. You can see Poisson distribution, log link. It's doing a residual pseudo likelihood because we have a random effect, and we're in GLIMMX. We're non-normal. So if I look through all of this, I see all of my output coming out for this. There's my solution for my fixed effects. There's the type 3s. There's the random effect for site. Again, remember that is in the log form because it's on the G side. But there's the BGLIMM code. Wow. Yeah, pretty much almost seems like you're just changing what procedure you're running this in. Now notice this time I put all the diagnostics and all the plots in, so you're finally going to see some of the diagnostic help that we do get. And I'm going to just point that out to you briefly as we pass through this. Notice in this situation, do you see that it says Gammerman conjugate? That means there are some things in here that did not go full conjugacy in the problem, which means I will need to spot check for convergence in this situation. So that is a good thing to be on the lookout for when you're working with a BGLIMM structure. There's my class level information. There's my priors. But what I'm really going to be interested in is, can I trust these posterior means, posterior standard deviations? Did we converge to an actual answer? So let me talk to you about the different diagnostics. There is autocorrelations in the posterior. The rule is, as you get, think about it, this uses MCMC. It uses a Markov chain. And the Markov chain where you're at now helps you figure out where you're moving to next, right? So the idea is there's going to be autocorrelation, because if where I'm at now helps me figure out where I head to next, yeah, there's going to be a dependency there. But as I get further away from my original start point, I want that autocorrelation to go to 0 as quickly as it can. So you look at each row and you want to see that as you get further and further away, more lags back, I want to be having my autocorrelation go to 0 as quickly as possible. This is the tabular form of this. There's going to be a visual picture form of this later on that I will show you. Effective sample size. This ESS statistic, you want that to be pretty much as close to your saved chain length as possible. But most people look at me and say, Danny, how close is close enough? I don't like using the ESS statistic. I like using autocorrelation time. Here's what that is. Hey, if I'm at position this, how far forward in the chain do I need to go to be effectively independent of where I left? This says it's roughly between 2 and 3 steps. 2 and 3 iterations get me effectively independent from where I left. That's actually good. Now, most people say, do you have a rule of thumb for autocorrelation time? Yes. My use that I did, we had a boundary on 3 or less. I give a little bit of wiggle room between 3 and 4, but 3 or less is typically what we like to see. Now, is that across the board the rule? No. Different areas can have different viewpoints on what that autocorrelation time should be. But that is how you can tell if the mixing between your prior and your data is working well in that particular idea. If something's going on here, you might want to thin the chain more and make the chain a little bit longer and thin it a little bit. And by the way, efficiency is nothing more than 1 over autocorrelation time. Monte Carlo standard errors. When the Monte Carlo methodology is invoked, it adds variability because of its randomness that's involved. This is how much variability is added into the problem for each of the parameters. This is the posterior mean. I want that percentage to be as small as possible. So I want to see things around the 1%, 2% or less, definitely, in this type of a situation. So typically it's less than 1% would be nice for here. You definitely don't want to see anything getting high in this territory, because then that basically means that the Markov chains, that the posterior variability is composed too much of the variability that the Monte Carlo invoked. Gavecki, I want my posterior mean at the front of the chain and at the back of the chain to be equal. That's called stability of the mean. The Gavecki tests that. It looks at the front of the chain, the back of the chain, is the mean the same? Yes, I said p-values are not used in Bayesian, but they're not used when it comes to the idea of picking if a variable is significant or not. I can use it in the Gavecki test. So I'm going to look for, I want everybody non-significant here. If I see significances, I've got a problem in that particular idea. Rafferty-Lewis, most people always ask, Danny, how far do I need to go? How many iterations do I need to go? This is an iterative thing. How do I know when I have a long enough chain? Rafferty-Lewis is one of these statistics to tell you. Look at the dependence factor. If these are bigger than 1, I'm not really concerned about the variance here because that's one of the things that's got the conjugacy. But if I see greater than 1 here, I'm good. That means you have a long enough saved chain to adequately talk about the posterior percentiles. And that's good because your posterior percentiles are talking about your credible intervals. Heidelberger-Welch, do you have consistency in the variability of tracing out the distribution of the posteriors? And the half-width test is, do you have a long enough saved chain to talk about the posterior mean adequately? Don't you just love it when tests actually say passed or failed on it? Yeah, I love it too. Danny, something failed. oh my gosh, we have to try something completely different. We got to no, 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 no. These diagnostics are not a definitive yes, no. These are guides. If someone looks at this and says, hey, I've got some things that are showing up weird, I always tell people the first thing you need to do is confirm it on the picture. Go to the plots, confirm it there. If you see something happening there, then we really need to do something. In some of these situations like this just might mean, hey, I might need to iterate further to get a longer save chain. That's what this half-width test is basically telling me in that type of an idea. Speaking of pictures, these are called TAD plots, trace, autocorrelation, and density plots. So basically, through the 5,000 iterations, this is a picture displaying what was the value of the beta not parameter at each of the 5,000 iterations. Again, I want consistency of a mean. I want consistency of a variability. I want to see the autocorrelation going to 0 as quickly as I can. The trace plot and the autocorrelation plot help you with convergence. Do not use the density plot to judge convergence, because that picture can still look good and you could have the worst convergence in the world. The density plot is actually a visualization of what the posterior for that parameter is looking like. So do you know what's a good thing that you can use this for? This is a way that you can visualize if a variable is helpful or not. Remember, these are beta hats, right, in my problem. So if I look at this, 0 has meaning to me. That means if the parameter estimate beta hat is 0 in a regression, that parameter is, that predictor variable is not needed. It's not helpful. So what you're going to be looking for is 0, in this case, under the peak. Because what does that mean? That means I can't tell the difference from what I am in 0. But if 0 starts heading to these tails, that's a better viewpoint of saying, I think that's an important variable to keep. See, I don't have p-values to do this. Now, I can save out the chain, you should, and look at something that's called posterior proportion of positivity. Basically, try to figure out what proportion is negative, what proportion is positive. And you want that to be away from 0.5. The closer it is to 0.5, then that means I can't tell the difference between you and 0. But these are the plots that I'm talking about. If you get anything that gives you any concern in the diagnostics, you go here. You try to see if there's something visually standing out to you in that type of an effect. But I'm not really seeing anything that's problematic in any of this. So I want to show you. Here's the comparison. Remember, I was using non-informative priors, so I should somewhat emulate what's going on with GLIMMX. Again, you have to remember, though, it was using a pseudo likelihood in that type of an idea. So pseudo likelihoods have a chance of being a little bit more different than BGLIMM, because remember, the pseudo likelihood is doing that first order Taylor series expansion to try to get to fit with pseudo data as close to my data as I possibly can. But you can see it's pretty close with those types of ideas. Anybody in here a repeated measure user? Anybody here do repeated measure studies where you look at that R-side matrix? Here's an example of heart rate with a repeated measure. So this would be me looking at things at 1, 5, 15, 30 types of situations. There would be your PROC mixed. The parameter estimates that you're talking about there with the VC site being different, again, it could be a sample size issue with that. Again, always be on the lookout for asymptotic issues when you're doing mixed models inside of a classical realm. And again, I might have had a situation where I didn't have a lot of observations per site or something like that. That causes an asymptotics issue, which would mean that my Bayesian viewpoint might have the better answer than what the classical can get me. So always be on the lookout for any issues with asymptotics. There's my mixed call with my repeated, so that I'm doing an unstructured based on patient. You can see all of those lovely parts there. Gotta love it when you're getting all of this part of the output, right? All right, there's my fixed effects. There is my BGLIMM. Look at that. Ain't that lovely? Now, if I go through here, notice You're used to seeing this, aren't you? There's that unstructured. So this is actually giving you what it believes is the posterior mean and those posterior standard deviations. And again, I can go through and check all of the diagnostics and everything along those lines, and then get to the pictures. And once you get to the pictures, guess what? You even get the pictures for those components of the G side and R side if those are the ones that you have actually requested. So that actually, everybody, is kind of our little introduction there. We've got about 10 minutes left. I definitely do want to thank everybody for participating and being here. And you've got some really good questions. We're going to start talking more about those questions more so here in a second. But let me stop the sharing real quick and let me do this real fast on the screen there. That QR code is my digital business card. That is where you can find my bio, links to a whole bunch of things here from our education division. That is where you'll find, you can add me as a contact to your phone, where you'll have my email address that you can contact me. It's got links to blogs that I've written and YouTube videos that I've put out. And yes, I do have several blogs that are out on Bayesian analysis. I do see some questions. Let's see if we can clear it up. The proverbial question. Does BGLIMM have a FIRST option? Not right now. What the best thing I would suggest for the FIRST is that would have to now go to an MCMC currently, and you would have to actually write that out in terms of coding it, of what the FIRST does in that type of an idea. Again, that is another thing that I do have on the list over to the developers, but again, it's going to be based on their timeline of what they're kind of doing with that. Let's see. What release of SASSTAT will BGLIMM be available? It's been available since 15.1. Since 15.1. If you've got anything past 15.1, you are golden when it comes to that. For effects importance, is it possible to do Bayes factors with BGLIMM? Follow up with me on that one. I want to know kind of what you're talking about Bayes factors a little bit. I want to kind of hear a little bit more about your problem with that. Let's see. Generalized memos are not reliable because data manipulation essentially invalidates procedure. Thoughts on that? I haven't really gotten too much into that data manipulation viewpoint with that. The one thing that I do know that I love about the Bayesian twist on this is you can do a lot of sensitivity analyses. And sensitivity analyses is what really makes classical statisticians feel a little bit more comfortable with what's going on inside of the Bayesian realm with that type of a viewpoint. I unfortunately have not had too much of a that type of an idea. Oh, yep, sorry, I'll read that out loud. But I have not heard too much about the conversation about the data manipulation part that you're referencing there. If you could send me any type of references or any type of papers, that would be great. And then I could probably try to chime in on that. But I'm not aware of that argument or that conversation that's being happened. How do you know when to do Bayesian analysis? What are the conditions in data that lead to Bayesian analysis? There's really no conditions in the data other than the possibility of the asymptotics breaking down. But again, the way that you know that you're going to want to possibly move into the Bayesian realm is the type of questions that you're answering. Do you want to ask things that are more probabilistic? Do you want to be able to speak about a credible interval rather than a confidence interval in those types of ideas? That is those big times when you would decide. Or you really want to say, hey, you know what? I've got this subject area expert that's been working on this for 30 years. They're telling me something. I want to include it. So that's the main thing about that, is that classical statisticians go data only. That's it. Can you use PROC BGLIMM in 9.4? Absolutely, as long as you have 15.1 or more recent. I did reference the Jupyter notebook that I was using with this. Not sure, depending on, again, I'm using VIA for learners on mine for that in terms of the SAS kernel. I do know that there have been some SAS kernel usage of being able to utilize outside and connecting from VIA a different way, not in a VIA for learners territory. That is something that we could probably ask to a few people, or I would suggest go to the communities pages in the SAS communities area. those questions, you might see people asking questions there that might have already been answered with that. So that actually just cleared the Q&A. Excuse me. But any other questions, concerns, thoughts? And I did see people were saying thank you for the seminar. Thank you guys so much for attending too. For those that might be heading to Midwest SAS Users Group at the beginning of October, I will be there. Come by, say hi if you are interested. I will be giving this again. Can I share the code? I have a PDF of this entire thing that I've shown you and the Jupyter notebook that I have provided. Those will be disseminated out to everybody. So that way you can actually copy and paste. And I even included the data for you. So the data is sitting there. You can just copy and run that in a data step. And then you can go ahead and have a field day playing around with BGLIMM with the data sets that I used for these examples. So I know that you guys really love to be able to do stuff like that and be able to kind of recreate exactly what I was doing here. So I wanted to make sure that you had that. And be on the lookout. I might be at Innovate next year down in Grapevine, Texas. Don't know if I'll be doing any Bayesian talks there, but you know, if you find me, you can always stop me and talk to me about Bayesian. I'm totally fine with that. Will you teach a class on BGLIMM? Okay. Our current Bayesian class did not have BGLIMM in it, and because it was written before BGLIMM came out. I am in the purposes right now. My goal from the end of this year to the beginning of next year is I am going to try to reorganize our introductory Bayesian class to have a chapter dedicated to BGLIMM. The developers want me to do this. They've asked me to do this. I've wanted to do this, and I'm finally going to try to structure that out and work through that type of an idea. So keep an ear out, watch for our Bayesian course that's currently available, and when you see the description change, that is when that will be ready to go. But we do definitely want to, because more people are using BGLIMM now than probably using the Bayes statement. So I'm going to try to see if I can offset that in the course. So, but thank you for proving to me that that's what you guys want inside that course. So we're on the same page with that. Anything else?
I believe we're just getting to the end of our session here now. On behalf of myself, Danny, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.